Hello everyone, and welcome back to the garage. This is part 3 of the 1978 Williams Phoenix Pinball Restoration Series. In this video, we're going to continue diagnosing the soundboard, we're going to get the lamps working, and we're also going to do some under the playfield repairs involving the drop targets. So, let's get started. Alright, so while we wait for that 6502 processor to arrive, I also went ahead and ordered some additional components like transistors, diodes, and capacitors, just so I could do a full recap on the soundboard. I don't think it needs it, but I'm going to do it anyway. I ordered transistors to fix the driver board problems, and I ordered some diodes just in case we ran into a shorted diode. But I figure while we wait for those parts to arrive, let's rebuild the flippers, because the flippers in this machine are very loose. This is not the coil moving, that's how loose the flipper is, and the one on the right is the same way. So obviously we need to install a Williams flipper rebuild kit into this machine, and I have one right here. Flipper rebuild kit, Williams 1967 to 1979. So installing all these parts should result in flippers that operate much better. I may not need to install all the parts like the coils, because I think the coils in this machine are just fine, but it would probably benefit this machine long term if I were to just install everything, like new plungers and links for the flippers, new coils, new assemblies, new everything. So I think I might just go ahead and reinstall all the parts into this thing, just so that we can have the best flippers in this game that it can have. So here are the current flipper assemblies in the Phoenix. As you can see, they're original. They have not been modified. And if I go ahead and move the loose flipper, you can see I'm moving the flipper right now, and it's not doing anything. So obviously something in this part of the assembly is very loose. And I imagine that I could tighten that with these screws, but I cannot get those screws to budge. They will not tighten, they will not loosen, so when I do install the rebuild kit, that's going to be kind of a process to get those screws out. So we'll see what I am able to do here. Okay, I was able to get those screws out with a socket wrench, so let's go ahead and pull the flipper bat out and see what that looks like. So here's the flipper bat, and as you can see, the play is coming from here. I'm able to turn this, so maybe the metal piece in here is broken, and this is what is going on. The metal piece broke off of the actual assembly here, so that's why there's play. As you can see, I can move this. So we don't need to install a rebuild kit, we need new flipper pieces. And that probably is going to result in new flippers. So that will have to be done. And here's the one on the left, and as you can see, it's got the same problem, and it's actually a little bit worse. So this game is going to have to get some new flippers. Okay, my order from DigiKey arrived, and along with that order, I got all the capacitors that I need to recap the rest of the soundboard. So the only ones I still have left to do on the board are these three. So I'm going to go ahead and solder in those new capacitors, and we'll see if it works. I don't think it's going to. I really do think the CPU on this board is bad, but if I've already replaced 3 capacitors on it, I might as well just do the rest of them. So I'm going to go ahead and fully recap this board, and then we can put it in the machine just to see if anything's different. And there we go. That is what it looks like after all the new capacitors have been installed. And one trick you can do with axial capacitors, like the old one here was an axial capacitor, when you're soldering in a radial capacitor like this one and the leads are super far away, just cut off the leads to the old cap and use them as basically extensions to the new capacitor leads. And so that's what I did here, because as you can see, the 2 spots to solder in the cap are really far away. So that basically lets you solder in a cap without having to use any wires. So this soundboard has been completely recapped, so let's go ahead and put it in the machine and see if anything changed as a result of replacing the capacitors. All right, I reconnected the soundboard. Let's go ahead and turn this on and just see if anything's different. And just as I thought, we still get the loud hum out of it. So capacitors, it was not the problem. So we'll have to wait for that new 6802 to arrive, and then once we put that in, then we'll see if things are different, because this board is just acting like it's not even starting up. So we'll go ahead and wait for that, and then hopefully it'll work after that. So while we wait for the new CPU to arrive for the soundboard, I think now we'll go ahead and take out the driver board, and we can take a look at that burnt transistor and see what we can do to repair the lamps and the solenoids, because that is all controlled by the driver board. All right, I've pulled the driver board out of the machine, and I have confirmed that this transistor right here, the one that was getting extremely hot, is indeed bad. So I'll show you how to check a transistor, and you'll see that the readings on this specific one are different from all the rest. So to check a transistor, first thing you have to do is put your meter into its diode test mode. Then what you want to do is you want to check 4 different positions on the transistor. The first being the middle lead to one of the end leads. And as you can see right now, we have about a 1.1 voltage drop. Now this is being tested in circuit, so it might not be completely accurate, but it should give you a basic idea if the transistor is good or not. So now you want to do is flip the leads and test the same points, and we should get nothing. And as you can see, we have nothing. And now what you want to do is test the middle lead to the other end. We have about a 1/2 volt voltage drop right there. And then we want to flip the leads again, test those same points, and we should get nothing. And we have nothing. So that transistor is good. But if we check the bad transistor, which is this one, you see we've like basically 0 voltage drop. So that transistor is shorted right there. And if I flip the leads, instead of getting nothing, we get the same reading. So the diode, that is this part of the transistor, is shorted. And if we check the other one, you can see it is shorted out as well. So this transistor has turned into a complete short across all 3 leads. So that transistor will absolutely need to be replaced. And I was checking the rest of the transistors just now, and we might have a problem with this top one as well, because I'm testing it here and we have nothing. And then if I turn the leads around and test it again, we also have nothing. So it looks like we have an open connection between these 2 points of this transistor as well. And these transistors are the lamp column driver transistors. And if these are bad, that will absolutely affect the lamps in this game. So how these Williams systems drive the CPU controlled lamps is all of the lamps are connected via a matrix of rows and columns. And these transistors are the column driver transistors, and these are the row driver transistors. And I checked all of the row transistors, they're all good. It looks like it's just these top 2 transistors for the columns that are not working. So I bought a brand new set of tip 42C transistors, and I'm not going to replace all of them because not all of them are bad, but I'm just going to do these top 2 for right now, and that should fix the lamp problem in this game. So I'm going to go ahead and desolder these 2 transistors. I'm going to put a new one here, and then I'm going to retest this one out of circuit and just see if it's bad. So I'm going to go ahead and get those replaced. Okay, I went ahead and desoldered both of those transistors. I threw the bad one away. But if I go ahead and test the one that looked like it had an open connection, if we go between here and here, it's open. And if we swap the leads, and there was a false reading there, but it is also open. So we have 2 bad column transistors on this board. So I'm gonna have to replace both of those. And it was funny because I was checking these column transistors earlier. I could have sworn this top one was good. So now I'm gonna have to do a sanity check and go through and check all these other column transistors and just make sure that they are still good. And yep, I just checked all the rest of those transistors and they all still seem to be good. So 2 bad column transistors. That will absolutely be causing what we were seeing with some of the lamps not lighting at all and some of them lighting up when they weren't supposed to. So I'm going to go ahead and put new transistors in those 2 spots. Okay, so I have those new transistors installed, but I'm looking at the data sheet for those specific transistors that I installed, and I think we might still have a problem. Between the collector and emitter, there should be nothing in both directions, and that is the case on this one here. Nothing, and then if I flip the leads around, nothing. But if I test this one between collector and emitter, we have nothing there, but then when I flip the leads, we have a 0.8 voltage drop. So I don't know if we still have a problem with a transistor here, because that's possible. We could have a bad collector to emitter on one of the other transistors, or there's a problem upstream of the transistors, like there's a problem in something else that drives the lamp columns. So I'm half thinking that I should replace all of the transistors. I'm just trying to kind of make sense as to why that would be, because it's not like there's a short between those two. It's got a voltage drop. So did I install the transistor backwards? No, I didn't. It's acting like I installed the transistor backwards, because if I go between, if I go between base and collector, we should have a voltage drop on one side. So right there we have nothing. If I flip the leads, we have nothing. So it's acting like I installed the transistor backwards, which is really odd. And I did not install the transistor backwards. The other one acts normal between base and collector. If I go between the two here, we have a 0.6 voltage drop there, and then on this side we should have nothing, and we have nothing. So maybe that's just because it's in circuit and it's acting weird. I have no idea, but my thought is we have 2 brand new transistors. They should be fine. But if I go between the collector and emitter on the other transistors, the ones that are already in here, if I go to the side, see we have a 1.3 volt voltage drop. I'm gonna go grab that other transistor that I threw away, and I wanna see maybe it's actually good. Yeah, I falsely accused that transistor of being bad, so we didn't have 2 bad transistors, it was just the one. So I'm gonna keep this one. I'm not gonna solder it back in because now we have a new one in there, but I'll put this back in my parts. Okay, so I'm not really understanding what's going on here, because in this transistor, we have nothing across collector and emitter. On this one, we have 0.8 volts across the collector and emitter. And on the rest of these, we have like 1.1 volts across the collector and emitter. So I don't know why that would be, because the only thing that the collector goes to on all of these transistors is the connector down here. That's what all these traces are for. It's going to each collector of each transistor. And then the emitter, all the emitters are tied together on this singular trace here. So I don't know why that would be different, because if I test between the emitter on this transistor and the collector on this one, we get a voltage drop. So unless, I don't understand why that would be. Why would one transistor be affected but the others not? So there must be another bad transistor in the column transistors, because if I test between this one, we have nothing, and if I test between this one, we have something. And we have something on every other transistor in here. So like that one, 1.3 volts voltage drop across collector and emitter. This one, 1.1. This one we have 1.1. Here we have 1.1, 0.3. We have 1.1. So I think I'm gonna have to pull all the transistors out. I'm not necessarily gonna replace them, but that should not be happening. They should all be acting exactly the same. So I'm gonna go ahead and pull all those transistors. All right, well, I took this transistor out and it tested perfectly fine out of circuit, so I'm gonna just assume that that's just an in-circuit problem that just is happening just because they're in circuit. So I don't think there's anything wrong. So now what I'm gonna do is I'm gonna do a little upgrade to this board that a lot of people with these Williams boards do. So what I'm gonna do is replace all of these resistors right here, because In Williams' first solid-state system, System 3, they had 2-watt resistors here. And then in System 4, which is what this board is, they upgraded these to 3-watt resistors. And the reason they did that was because the 2-watt resistors ran very hot. And even with these 3-watt resistors, they still run quite hot. And as you can see on the board, you can see burn mark across this entire area where these resistors are. So what people have done, and what I'm going to do to this board, is install brand new 5-watt resistors. So that will make it so that when the new resistors are in here, it won't run as hot right here, and so those resistors will last much longer. Now, I don't think there are any problems with the resistors that are on here, but I do notice that a couple of them are quite cracked, and that's just simply because these things get so hot when they run, the outer shells will crack. So I'm going to replace all these resistors here with brand new 5-watt resistors, and then the board won't get so hot in that area. All right, and there are all the new 27 ohm 5-watt resistors installed. So now the board should not run as hot in that area. So at this point, with all the resistors replaced, with these 2 transistors being replaced, we should have fully working lamps now. So let's go ahead and put this board back into the Phoenix and see if all the lamps work. All right, I put the board back in, and I also went ahead and put warm light LEDs in the back box and underneath the playfield. So let's go ahead and turn this on and see if the lamps are now working. They're different, but they're still not working right. Well, more of the lamps are working than they were before. The player lights are now working. These 2 lights are working. They weren't working before. For whatever reason on the camera, the lights don't all show that they're working. See how they're kind of like going in and out like that? That is just the camera. They are all flashing, so I don't know why it's doing that. The credit light here is working now, and you can see it on the camera. That was not working before, so it looks like replacing those 2 transistors definitely made things better, but there's still obviously a problem, so I'm gonna have to figure that out. All right, let's go back to the soundboard for a little bit, because I received my new 6802 CPU for this board. So I'm gonna go ahead and pull out this one and put in a brand new one. And that can be done really easily with this chip puller. This is an amazing tool for pulling out ICs out of sockets. And speaking of sockets, I did read about these sockets online, and apparently they're not the best quality, but I did go ahead and check for continuity with a multimeter on every pin on every socket, and they're all good. So it seems like the sockets are fine right now. If one does go bad, then of course I'll replace it, but for now I'm just gonna stick with original sockets. So here's the new CPU, and according to the date code on it, it was made in the 33rd week of 1988. Oh, this is a Williams CPU. It's got the Williams logo on it. Cool, so it's actually a genuine part and not a new 6802. So that's cool. This obviously was pulled out of some other machine. I will go ahead and install this one. And there we go, there is our new CPU. So now what we can go ahead and do is power this board up again. Okay, so right now the board is running. I'll go ahead and turn the volume pot all the way up. And in order to get sounds out of it in this state, what you can do is hook another clip lead to ground and then ground each pin on this connector here. And if things are working, we should hear sounds out of this thing, I would think. Now that's not promising. Maybe the problem wasn't the CPU. I know I didn't do the best troubleshooting when we first looked at this, but it just seemed to me like the CPU was getting quite hot. So it is possible that this isn't going to work unless it's installed in the game. So I'm gonna go ahead and turn this back off, put it inside the game, and we'll see if we have sound that way. All right, I have the soundboard in the machine, not screwed in, but I do have the connectors installed. So let's go ahead and turn it on and see if anything is different. And that's a no. Yep, that was not it. Okay. So it was not the CPU on the soundboard that was causing the issue. So, we have a problem somewhere else. Okay, I think I just figured out the problem with the sound with this machine, because I was able to get it to work for a second just now. If I go ahead and just turn this pot, eventually it'll work, because I got the sound out of the speaker, because right now I'm in the solenoid test. You can't see it. Oh, there you go. 09, that is the, which one is it? Here, 09, 10-point sound, so you should be hearing that sound. And if I just turn this pot, eventually, do you hear that? That's the correct sound. So I think we have a bad connection in the pot here. So I don't think there's anything wrong with this board at all. See that? That's the first time I've ever heard sound out of this thing. It has to be the pot. Yeah, look at that. Oh, now it's not doing it, but yeah, you can hear those little bits of sound coming through. It has to be the pot. So I'm gonna go ahead and take a look at the pot. Even though I sprayed it with contact cleaner, even though I checked the resistance on it, there must be a bad connection inside the pot. So I'm gonna go ahead and take a look at that. All right, so I pulled out the pot out of the soundboard. This is the back cover for the pot. This is the actual pot itself. Those two contacts right there, not totally in focus, but you can see them. Those are what scrape against the internal carbon track of the pot, which is right here. And as you can see, that looks quite dirty, even though I sprayed it down with deoxit. So I'm gonna go ahead and clean this up, clean the two contacts up that are on here, and we'll see if the pot works better now. All right, I put the pot back together and I resoldered it into the board, and the inner contacts were actually quite dirty. So I cleaned them up and I bent them down a little bit just so the inside of the pot would have the absolute best contact. So let's go ahead and turn this thing on and we'll see if we no longer have a hum. Look at that, no more hum. So now I'm gonna go into the sound test for the game, which is part of the solenoid test. Oh no. What? It was just working. Oh, there we go. Before we do sound test, actually, let's just start the game. I want to hear this thing's startup sound. It would help if I had a credit in the machine. There we go. So let's hear this thing's startup sound. It didn't make the sound. Why didn't it make the sound? So now I'm going to go into this thing's sound test, which is a part of the solenoid test. And one little trick I found to get the diagnostic button to actually hit it with the playfield open is just to grab one of these things and just stick it in there and hit the button with it, because you can reach it. So I'm going to hit it with this, and it just went into diagnostic mode. So that's a little trick that I figured out if you want to hit that button when you have the playfield open. So now what we'll do is we'll open the coin door, try to do that with one hand. Hit the advance button, it'll go into display test first, then lamps if you hit it again. Well, you have to flip the switch to auto, then hit advance, that goes to lamp test, then solenoid test, and we should hear sounds once it reaches number 9. 6, 7, 8, 9, and we hear nothing. Oh, now it went to 10. 10 is the 100-point sound, and I don't know why we're not hearing it. Oh, well, now the hum's back. Well, you can hear it. That's weird. Well, it worked there for a second. Did you hear that? So obviously the soundboard is completely fine. It's just the connections inside this pot. So I'm gonna have to take it apart again and really clean that pot, really clean up the connections to make it reliable, because obviously it is very dirty at this point. Well, what we can do is we can go up to 11, which is the 1,000-point sound. So now we're at 11. Let's see if we can get it to make that noise. Yep, so that's working. And it's good to test all these sounds because the sounds are actually triggered off of the driver board. So each sound is triggered just like a solenoid. Oops, I hit the flipper. Let's go to number 12, which is the 10,000 point sound. So now we're at 12. See if we can make it do it. Yep. So it's working. And then the last sound, according to the solenoid sheet up here, you can see we have 10 point, 100, 1,000, 10,000. 13 is the sound alternator. And I think that is the system's like startup sound. It'll make kind of a weird sound when it first starts up. So let's see if it does that. I hear nothing. So maybe that solenoid transistor's bad? Hard to say. But we do know that now the problem is this potentiometer right here. So I'm going to go ahead and get that totally fixed up, and then we should have sound in this game again. Well, I decided that I would put the original CPU back in the soundboard, and guess what? It works. So the CPU was never the problem. It was just a dirty potentiometer on the soundboard right there. So I went ahead and ordered a new 5K ohm potentiometer for the soundboard. And so in a couple days, I'll be able to install that, and then the sound will be working absolutely perfectly once again. All right, my new flippers came, and so I took out the old ones and put the new ones into the playfield, so they're installed right now. And as you can see, now there's no more play. They are nice and strong flippers. And I was playing a few rounds with these flippers, and they work perfectly. So that's another problem in this machine fixed. All right, well, I just discovered something pretty startling about this machine that I think might fix both the soundboard and the driver board up in the back box. So here's what I found. This is the original power cord to the machine. I desoldered it and pulled it out. And I did that because if you look on the end here, someone cut off the ground pin. And I don't think that is correct because there is a sticker on the back of the cabinet that says shock hazard if third wire ground is defeated. And I looked in the manual and it says do not cut the ground pin. So obviously someone did that. They cut off the ground pin because if you take a look here, there were 3 wires being used on this cord. So I would think that if this machine wasn't being properly grounded, we could have all sorts of problems with the sound, the lamps, you name it. So I went ahead and I bought a new power cord and I wired it up exactly how the old one was wired. The hot side gets wired right to this fuse right here. Ground goes to the middle point here of this line filter, and then the hot side goes to this other point right here. And I checked connections with my multimeter and it all checked out good. It is the same as the schematic. I made sure it was all correct. So everything checks out. I got a new cord with a ground lead, as you can see, wired into this machine. So now I'm going to go ahead and plug this in and we'll see if things change. All right, so at this point in terms of the soundboard, I am completely at a loss as to what to do. Because usually on things like this that are broken, it'll kind of give you a lead. Like there'll usually be a tell as to what could be the issue. And this board definitely gave me all sorts of leads, but every time I tried to mitigate that lead, the board still had the exact same faults. So let me tell you what I've tried so far to fix this board. I replaced all of the electrolytic capacitors on it, all 6 of them. I replaced the 6802 CPU to see if that was the problem, and it wasn't. I have replaced the audio amplifier chip with a brand new one, and I've even replaced the volume pot. I put the old one back in, but I had a new volume pot in there. I reflowed connections on basically like 60% of the board, including each of the main 3 connectors here, because what was going on was As you heard in the previous clips, I was able to get sound out of this thing, and I still am sometimes, but the sound will only come through when the volume pot is at a specific position, and if the volume pot is like below 80%, like in terms of the rotation, it will just go right back to AC hum out of the speaker. So I don't know if it's a volume pot issue, because if I shake the pot in a position where the sound is working, if I just rattle it, it'll make static in the speaker. So that's why I thought the volume pot was bad, but I replaced it with a new one and it does the exact same thing. One thing that I did find recently is right here, this is a little tantalum capacitor right here that goes into pin 1 of the audio amplifier chip. If I just rested my finger on that, I could get sound out of the speaker that was connected to this. But it wasn't the correct level of amplification. Like, for example, if I had this thing turned all the way down and I did that, I would get extremely loud sound. So I replaced this capacitor. That didn't solve the issue. I cut away the solder mask on this trace, just maybe in case the trace was cracked somehow. And I soldered the pin 1 of the audio amp to the other end of this cap. That didn't do it. And it seems like all the traces on this board are good. So at this point, I'm not really sure where to go next, because the bridge rectifier is good. The voltage regulator is good. This board does use the crappy sockets that are known to go bad, but I checked between every pin on the 3 chips here and every pin of the socket, and they all have continuity with each other. So the sockets on this board are not problematic. So I just don't really have a lead. I mean, I could do some deep oscilloscope testing with some of these other chips here that I haven't really looked at yet. Their solder connections look good, but it's really hard to tell what should it be normal, because what I would think to be normal is you would have a square wave going from ground to 5 volts, and that would constitute normal activity. So things like that are normal. But if I see something going from like 3 volts up to 5 volts, that would be kind of not normal. And I did see that on the CPU and on the peripheral interface chip here, but obviously those chips are working because we are able to get sound out of this board. So at this point, I'm not sure where to start. So if anyone has any comments about the specific issues that I'm dealing with here, and if you have an idea on where I should begin troubleshooting this, please let me know, because I would like to get this board working. In the meantime, just to get the sound working out of this game, I went ahead and bought a new aftermarket Williams System 4 soundboard that is going to work in the Phoenix. So once that arrives, I'll be able to put that board in, and we should be able to get sound out of the machine reliably. The volume pot should make the volume go quieter and louder, which is not what it's doing on this board right now. So this is just going to be kind of in my parts stash for now. If anyone has any ideas on to how to get this board working, let me know in the comments. For now, we're just going to move on to the lamp and the solenoid problems. All right, so now let's go back to the driver board. And after looking at it some more, I am pretty convinced that we are still dealing with a column transistor problem. Because if I go about checking these 2 points right here, this is just a random transistor, you can see the voltage drop is 1.1 volts. But if I do it on this one, it's 1.3 volts. And that's odd, because all of these are tied together, and then all of the middle ones are going to just the connector right here. So that's weird that there would be a voltage drop that is different between 2 different transistors. And if I check the rest of these, most of them say 1.1 volts for the voltage drop. So I would have to imagine that the outliers, the ones that say 1.3 volts, are the bad ones, like this one. So we could potentially have 2 more bad transistors. This is the one that I replaced earlier, so this one's going to be different. See, this one's 0.8. And then if I do the top one up here, which I put an original transistor back into, it's 1.2. So I think what I'm going to do is take out the transistors because with this driver board installed, I figured out something new about the machine. So if I unplug the connector that powers the back glass lighting and I put the machine in lamp test, the transistor here no longer gets hot. But I did notice that when I put the machine in lamp test and I have all of the lamps connected, this transistor here, this is the one that drives column 4, will get hot. And all of the lights on column 4 are having issues. So you would think that this transistor is bad, but I had it out of the machine before and I checked it and it was fine. But if I take out the playfield lighting connector and I just do the lamp test with only the back glass lights lit, this transistor doesn't get hot. So that almost suggests that we're dealing with a bad diode somewhere that is shorting out and making the transistor get hot. But I checked all of the diodes in the back box and every single one of them is fine. I didn't do any playfield diode checking, but if we don't have a bad diode in the back box, when we plug in the connector and it causes that transistor to get hot, there must be a short between one of the transistors that's making this transistor get hot, because this is the new transistor and it still gets hot. So the only columns that are being driven through the back box are 7 and 8. So that would almost suggest that we have a problem with the column 7 transistor. And this top one is the column 7 transistor, but I checked that one and it was fine. So I really don't know if we're dealing with just another bad transistor somewhere or what. So I think what I'm gonna do, just because we had one bad column transistor already, is I'm gonna take all the transistors out and replace all of them with brand new tip 42C transistors. So I'm gonna go ahead and do that, and we'll put the board back in, and that will rule out the problem of the column transistors. All right, the board is back in the machine, and I have all brand new tip 42C transistors installed right there. But when I went ahead and turned this on to check and see if things had changed, no change. All the same lights are lighting up when they shouldn't be, and so that did absolutely nothing. But what I noticed about these new transistors is they don't seem to get nearly as hot as the original ones, so I'm definitely going to be leaving those installed. But that only leaves a handful of other things that it could be that is causing our lamp problem. Of course, there is still the possibility of a shorted diode somewhere, but I don't think that's the case, because if I unplug the connector for the entire back box lighting, it will still have the same issue. And if I unplug the connector that goes to all the playfield lighting, we still have the same issue. So that, I think, kind of rules out the possibility of a shorted diode. So I think we still have a problem on the driver board. Oh, schematics. So I'm gonna explain the lamp matrix in this game a little bit, because I briefly went over it before, but I didn't really fully explain how it works. So this is the diagram of the lamp matrix for Williams Phoenix. And so how this works is each lamp is driven by a specific row and column. As you can see, we have columns 1 through 7. There's actually an 8th column, but it's not being used in this matrix. And we have rows 1 through 8. And so those columns and rows are driven by these transistors. These are the column transistors, and these are the row transistors. I checked all of these transistors and they were perfectly fine, so I don't think we have a problem there. And I don't think we have a problem with anything in the row circuit, because I wrote down all of the lamps that were acting weird, lighting up when they weren't supposed to, and just doing things that weren't right. And all the lamps that are affected are part of column 4. All of the lamps, if you trace out column 4, these are the lamps. As you can see, these little symbols indicate that that is a lamp. So that one says 8B25. So you'd look here, 25, that is the X2 lamp. So that would be this lamp right here for the 2X. So all the lamps in column 4 are having issues. So all of these. And we also have issues with column 8 And column 8 is hooked up to the insert board. That's what they call this section of the backboard here. Column 8 is used for that along with column 7. As you can see, we have column 7 and 8 right there. And all the lamps in column 8 are acting up as well. So at first I believed that there was a problem with the column 8 and 4 driver transistor, because whenever I put the machine in lamp test, those 2 specific transistors got burning hot. And so I had thought that maybe those were bad. But of course I had already checked the column 4 transistor out of circuit and it was fine. So I figured maybe we had a marginally bad transistor somewhere else. So that was kind of the rationale behind me replacing all of these. I just wanted to rule that out. So I did that and we didn't get a change. So obviously the column transistors were not the problem. And so what can happen is one of these diodes, that's what this symbol is, one of those diodes could short and then it would affect another column. But since I unplugged the playfield and backglass connectors separately and we still had the problem, that I think eliminates that possibility. So I think all of these diodes are good, and all of the diodes here, part of the backboard, are good too. So here we have the diagram for the driver board, and it's actually a very well made diagram because it separates each section of the board into little blocks, and it tells you exactly what those components are for. So I still think we have a column problem because all the lamps in column 4 and column 8 are acting up. I didn't see any specific row that was having a problem, so I don't think there's a row problem. So we have to look here. In this block right here, it says, where is it? Lamp column drive. So these are the column transistors that I just replaced. I replaced these resistors as well with 5-watt resistors. And it's a good thing I did that too, because there were a few cracked ones on there. These are the new resistors. And 3 of the 8 resistors were bad. So it's a good thing that I replaced those. So where do we go from here? Well, these column transistors are driven by pre-driver transistors, and those are right there. There are 8 of them. And if we look at the schematic for the driver board, this is just one of a couple sheets for the driver board. If we look right here, you can see we have lamp strobes 1 through 8. Those are the lamp columns. And so if we trace those back, each one of them connects first to the tip 42 transistors. These are the ones that I replaced, all of them. And then right here we have our 27 ohm resistors. Those are the ones that I replaced with new ones. We also have 2.2K ohm resistors. I checked all of those and they're all good. So those are not the problem. But right here we have the pre-driver transistors. I have not touched these or looked at them, and so we could have a problem there. We also could have a problem with these ICs that are right before the pre-driver transistors. As you can see, 4 of these are labeled IC14 and 4 of these are labeled IC13. So there's actually only 2 chips for that, and those control the lamp column and blinking, and it's these 2 chips right there. These 2 chips. And they don't get hot at all, so I don't think we have any IC problems because I haven't run across a single IC problem in this whole machine yet, but that is still a possibility. But what I think is the problem, because before the ICs go directly to PIA3, and that is the main chip that controls all of the lamps. And I don't think this chip is bad. So I am suspecting the pre-driver transistors. And the reason for that is because if I feel the pre-driver transistors that control column 4 and 8, they get pretty darn hot. Like, that wasn't burning hot, but I couldn't keep my finger on that for much longer. Let's feel the column 8 one. Ooh, yeah, that one's hot. So, and the rest of them don't get hot. The rest of the pre-drivers are like, this is a different one, barely even warm. But if I feel the column 8 one, which is right below it, Yeah, that's about how long I can hold my finger on there for because it's that hot. The rest of them, not even hot. And if I feel the one for column 4, yeah, that one's hot. So I think we might have 2 bad pre-driver transistors for column 4 and 8. So I went ahead and ordered those off of Mouser, and so those should be here in probably a few days. So while we wait for that, I think I'm gonna go ahead and take care of some switch problems that I noticed in the playfield so that when this game does work, when we get the lamp problems fixed, we can get right in and start playing it and testing it, because I did notice some switch problems throughout the whole game. Like, for example, we'll start a game here. I gotta load a credit into the machine. So we'll start the game. And you can see right now we have 0 points. If I go ahead and push, like, say, this switch, that did nothing. And I know that this switch is closing. So obviously we just have a bunch of dirty contacts on all the switches in this thing, because there are quite a few switches that are like that, especially these ones here. These ones don't always work either. Well, that one worked, but I have noticed that a lot of these switches have a hard time. And another thing I noticed is that the drop targets in this thing are not working 100%. So, for example, I'll show you what's supposed to happen. When you drop all of these targets down, you can see we're getting points. Well, it's not showing up on camera just yet. There we go. You can see I have 3,000 points. And if I drop each one, you can see the score increases. So the drop targets are working. Now what should happen when I drop this last one is the drop targets here should reset again. And as you can see, they do that. But the ones on this side do not. So if I go ahead and do all these, it does increase the score. Well, you can't see it right this second, but if I drop another one, you can see it does increase the score. So the switches for when the drop targets actually go down are working, but when I drop them, you can see it doesn't reset. But I know which drop target is the culprit, because if I move this third drop target back, it resets. So we obviously have a bad connection on this drop target right here on the little PCB that it's on, so that will need to be fixed. Another thing that I noticed is I don't think these targets are working right. See if I can get that one to work. Okay, there we go. This lane resets this drop target, so that's why that went back up. I don't think this one scores properly. Let me see. So right now we are at 45,000. Yeah, see, that one didn't score. So let's see if I push this back. Yeah, it's not scoring. So we have a problem with this drop target. It doesn't work at all. And then we have a different problem with drop target A. It's getting caught on the back of this rubber. So when you push it, it gets stuck. It doesn't want to go down because it's getting caught on here. So that will have to be fixed as well. And I'll have to figure out how I'm going to do that, because the rubber is in the correct position. It's just the drop target is like rubbing against this rubber super hard. And so whenever the ball hits it, it won't go down. The target works, so that one doesn't have any switch problems. But obviously, we have a lot of switch problems in this game that need to be addressed. So let's go under the playfield and see what we can get working again. Well, I opened up the playfield and I looked at this drop target right here. This is the one that wasn't working. And you can see exactly what it is. Well, I don't know if you can see it at this angle. Let's see if I can get in on it. We have a broken diode. And it's weird, it didn't break off at the solder joint. It broke off right at the base of the diode. So I'm gonna have to either try to solder that diode back on or replace it with a new one. So that's the problem with this one. And earlier on, there actually was another broken diode on this set of drop targets. I fixed it already. It was this one here. It broke off at the solder joint because I noticed that that drop target wasn't working. It wasn't scoring. So I resoldered that diode back on and now it works just fine. So that's working, but obviously we have a problem on the backside of this PCB right here. that is preventing the drop targets from resetting when they all get dropped. So I'll have to take off this PCB and clean the switches that are behind it, clean the contacts, and then that should be working. And then I'll go ahead and just clean the contacts on every one of these other switches for the in lanes and out lanes. And hopefully that should restore functionality to those so that when I push one of them down like that, it'll score reliably. And so after cleaning those up, that should be working fine. Okay, I was able to get to the 4 screws that hold this entire drop target assembly onto the playfield, so we can go ahead and kind of tilt it like this. And now you can kind of see the problem right here. We have a broken diode, and I might not be able to solder that back to here. I can tell that's where it went because it broke off like right against the base of the diode. I don't know if I can even get solder on that. So I think I'm just gonna go ahead and replace that with a new diode, and then this drop target should work. All right, there is our new diode, and I made sure to install it in the correct direction. So now the drop target should work in this game. So since I'm going to be doing some more work in the playfield, I am just going to test it out of the playfield. So what I'm going to do is, because this drop target does not reset when you first start a game, I'm going to manually put it back up into its reset position. Then I am going to load a credit. Then I'm going to start the game. And I am going to push that drop target down, and we'll see if it works. If I can give it room to push down. Did it still not work? Huh. It still did not work. Well, I haven't even removed this yet, and I figured out what the problem is, and it's actually a more serious problem than I was thinking. This is drop target A, the assembly for it, and if I look inside that PCB, there are 2 switches that make contact with the PCB contact. If I look at this one, I can see there's 1 switch, but the other switch is completely broken and missing. I can see like it just broke off. So I am going to have to build a new switch. So we have a missing switch, basically. So that would explain everything as to why that drop target isn't working. We did have the diode problem, but now we also have a switch problem. So I'm going to go ahead and remove that PCB, and we'll take a look at what it looks like right now. Okay, I went ahead and removed the little PCB. It's right here, just held on by 2 screws. Yes, this is hanging by the wires, and normally I don't like to do that, but I don't really have a choice right now. So I'm just going to leave that hanging right there. So this is the contact assembly that the switch is right on. But if you look at the switches on the other, where are they at? They're on here, I think. Yeah. So here are the switches. You can see we have a switch here, but this one is totally gone. There should be another one that looks like this right there. So I'm gonna have to figure out what to do about that, and hopefully I can make something work, because I don't have any switches like that. Okay, I looked through my spare pinball parts, and I was able to find part of a switch from an old Bally machine. And so what I think I'm gonna do is, I know it's not the right type of switch, but what I think I'm gonna do is I'm going to cut this to exactly where it's supposed to go. I'll take a look at this one to see where in the position it needs to be. I'll cut the switch and I'll make a hole in it so I can screw it on, and then we should be able to have a working drop target in the drop target right here. So this is a little bit of a hack job, but if I have spare switches and I know I'm not going to use them for anything else because they were part of old flipper rebuild kit I did, these are the old parts, I think I'll just go ahead and cut that switch to size, screw it in, make sure it's in the right position, and we should be good to go. So I'll go ahead and do that, and I'll show you the final result with that. So this is the final result I got with the flipper switch. So now I'm going to put the drop target back together, see if it works, see if I need to adjust it, and we should have a working drop target now. All right, I went ahead and screwed the PCB back onto the drop target assembly. So now if I push the drop target down, this is gonna be kind of hard to do with one hand. And of course the display is going to act weird, so give it just a second for it to come back on the camera. So if I push it down, let's see if I can do it. There we go, it now scores. So that little engineering job I did with that switch made this drop target work once again. New diode and new switch. It's all good now. So there's another problem fixed with the Phoenix. Well, I took off the PCB on the other drop target that was having problems, and what do you know? Another broken switch. But this one's not as bad. It still has its rear contact, so if I just bend that forward, then this drop target bank should reset when all of the drop targets go down. And with this thing in its switch test mode, I can verify that the drop targets actually work now. So if I go ahead and push down on the 4 drop targets there, that's one. There's another one. It doesn't show up in the camera. There it is. And then when I hit the last one, it should show that switch, and then it'll go to the switch that tells it that all the drop targets are down. So you'll see it go between 2 different numbers. So it went to 25 and then 29. So what that did is, as you can see, 25 says left drop target bank top, 29 is left drop target bank series. So it knows that all 4 of the drop targets are down. So when you're actually playing a game and you hit all 4 of these, now they'll reset. So that's another switch problem fixed. All right, let's turn our attention back to the driver board for a minute, because my pre-driver transistors from Mouser arrived today. So now we can swap over the 2 pre-driver transistors that I think are bad, and we'll see if the lamp problem gets fixed. The ones that I'm going to swap are this one, which is for column 8, and this one, which is for column 4, and both of these get very hot when running. And since we have problems with all of the lamps on column 4 and all of the lamps on column 8, it would make sense that if the main column driver transistors weren't the problem, then maybe these pre-drivers are. Because if all the rest of the columns and rows are working, I wouldn't imagine that we have a problem with these 2 chips here. This chip drives columns 1 through 4, and this chip drives columns 5 through 8. So I wouldn't imagine that these chips have any problems, and I wouldn't imagine that the main lamp chip, I think it's this one, would have problems either, because it's able to drive the lamps correctly on all of the other columns and all of the rows. So I'm going to go ahead and swap out this transistor and this transistor and see where that gets us. Okay, I pulled out these 2 transistors from the driver board, so let's go ahead and test them with a meter. So the transistors that were in this board are really nice because they label the base, collector, and emitter right on them, so I don't have to continually look that up. So this first one, between base and emitter, one way we should get a voltage drop between 0.4 and 0.9 volts, the other way we should get nothing. So if I can get on this transistor here. Okay, so nothing that way. Let's swap the leads. Yeah, we have an open connection between base and emitter. The other transistor, let's see if we have an open connection between base and emitter as well. So that way we have nothing, and this way we have nothing. So these 2 transistors are definitely bad. And just to verify, here's one of the new ones, and I am going to test out that one. So now we'll do the base emitter test on this one and see if we actually get a reading. So one way we should have nothing, the other way we should have a voltage drop. Hey, look at that, we have a voltage drop across there. So we indeed have 2 bad pre-driver transistors. So what I'm gonna do is, because we have 2 of them that are bad, I'm gonna replace them all. Because if we have 2 that are bad already, it's only a matter of time before the rest of them are gonna go bad. So I have enough to replace all the column pre-driver transistors, so I'm just gonna go ahead and replace them all. All right, the driver board is now back in the machine, and we have all new pre-driver column transistors right there. So Now let's go ahead and turn on this machine and see if all the lamps are working correctly. All right, let's see if the problem was indeed the pre-driver transistors. It was. It's working now. That was it. The lamps are working. So as you can see, no more playfield lights lit. That's how it's supposed to be. The shoot again light on the back glass isn't lit. Well, the lights still look weird in the camera, but I'll show you what's lit. The player one light's lit. That's normal. The game over light is lit. When you first turn the game on, the ball in play light will be lit. That's normal for these machines. But now look at the high score light. Well, look at it when it actually shows up correctly in camera. See how it goes off? And then when the high score comes back, it comes on. That is acting normally now. And we have a pulsing player one light. So the lamps in this machine are now fully working. So the problem with the lamps were a bad column 8 driver transistor and 2 bad pre-driver transistors for column 8 and column 4. So my theory as to what was wrong here, if you look in the schematic, I'll open up to the driver board. If you look right here, we have connections for lamp strobes 1 through 8, and those are the columns. And if you look here, these are the tip 42 driver transistors. Which one was it? The column 8 one was bad. Q77 was bad. That was the one that was shorted when we first looked at the driver board. I replaced that one, and I ended up replacing all the rest of them. But my theory as to why Q77 went bad is because Q76 was bad, and then the one for lamp strobe 4, I'm just following it real quick, and that would be Q68. So Q68 and Q76 were bad. And as you can see, these pre-driver transistors have a direct connection to ground. And so if these were bad, I think that the lights would not get good grounding, because the only other ground in the circuit, at least as far as I can tell, is on PIA 3, which is the main lamp driver controller, and that is on pin 18. As you can see, it goes right to ground. So if the lights on column 8 and column 4 weren't getting grounded, that would explain why they would remain on in situations where they shouldn't. Like the shoot again light, that always stayed on. The high score light, even when the high score was not being displayed, that would also stay on. I wish that would show up correctly in the camera. There you go. See how it went on when the high score came on, and now it went back off and the light went off? It is doing exactly what it's supposed to be doing. So there we go. We fixed one of the major problems of the Phoenix. The lamps are now working. So I've just gone ahead and started up a game. So let's go ahead and test some of the playfield lights to make sure that they're operating normally. The backglass lights, when I start a game, are just fine. You can't see it, but the ball in play, the player one light on the bottom, and then the player one light next to the display, they're all doing exactly what they're supposed to be doing. So let's go ahead and test some of the switches, and we'll add some totals to our bonus, and we'll see if that works right. So if we drop down this target, for example, that'll add 1 to the bonus. And as you can see, we got 1. Let's do this one. Did that one not score? Are you serious? I thought this one was working. Well, that one didn't score, so maybe we still have a problem with this one. Let's do a different switch. Let's do one of the out lanes, because that adds to the bonus. There we go. Look at that. Those lights were not working right before, and now they are. I'm just going to keep adding to the bonus here until we max it out. So that's working. We'll do it again. There we go. And I think you can go up to 29,000 on this game. Yep, that's the limit. 29,000 points is your bonus. Now let's test the multiplier lights, because those are having issues too. So if we drop all 4 of these targets down, that will advance the multiplier by 1. There we go, we have 2x. Let's go up to 5x. I'll go ahead and do the ones on the right just to test them. There's 4x. And there's 5x. So now let's test the Phoenix lights. I think these lights were working before, but in order to get those to light, you have to light 1 through 5 on the top row of lanes here. So let's do that. So 1 and 5 are connected together, and that just makes the game easier. So let's just go ahead and do that. So there we go. This game is set, and you can change this in the game settings to light P and H together and then have the rest of them light on their own. You can make it harder so that it will only light the P, but I'm gonna leave it just as it is. So let's go ahead and light this the whole way. So there's O. And you might have seen that this drop target right here, when it reset, it went up a lot higher than it should. That's because the bottom side of this drop target is broken, and so because of that, it can't stop at the right time. So I went ahead and bought a new drop target to replace this one. And this one also had the same problem, but I super glued it and it's been working so far. But I went ahead and just bought 2 drop targets so that in case this one does break again, I can just put in a new one. And I also bought a set of brand new stickers for these targets so that I can replace the ones in all 10 of them, because half of them look really faded. And so I like it to have fresh new ones. So that will all get fixed soon. For now, let's go ahead and light the rest of these lights. So there's the E, and so that will light the extra ball when you hit this target. So I'm gonna grab the ball and shoot it up there, and that'll light the shoot again light. As you can see, there we go. And the shoot again light lit up on the back box. So it's supposed to do that, and so now it lights at the right time. Let's go ahead and light NIX. There's N, there's I, and then we'll do X. There we go, there is the X. So all of those lights are working, and all of the 1 through 5 lights are working as well. So this game is working great now in terms of lamps. All right, let's go ahead and drain the ball, and we'll watch the end of ball bonus go down. We got a replay because we went over the replay value. And look at that, those are working correctly. So there we go. Lamps in this game are working 100% now. So that is one big problem solved on this pinball machine. And so that's gonna wrap it up for part 3. We were able to get the lamps working. The soundboard I wasn't able to get quite working, but that is something that I will tackle at a later time. Maybe I'll do a video about it if you want to see that. And we were able to fix the drop targets and make them reliable once again. But I'm sure the pinball diehards who are watching this video kind of cringed at the way that I fixed that one drop target with the flipper switch. So don't worry, I have since gone and went to Marco Specialties and I ordered the correct Williams drop target switches for all the drop targets in this thing. So all the ones that had broken or missing switches, the switches have now been replaced on those, so now they will be super reliable again, and there's no more hack job like I did on that one drop target. And so in part 4, we're gonna fix everything else. We're gonna get the new soundboard installed, and we are going to fix the driver board and get those 2 solenoids working once again. And after that, Phoenix will be a 100% working pinball machine. So look forward to part 4, and I will see you in my next video.